Hello there. I just want to quickly chat about how to sketch the graph of the first derivative of this function right here. This represents the number of coffee cups sold during the operating hours of, the coffee company in our activity. I think it's called Bean Buzz Coffee Company. And I gave you guys the hint to try a couple of strategic points, carefully estimate the slope at two strategic points. And I chose at x equals 5 and at x equals 10. And let me show you why. First, the really clear winner for a strategic point is x equals 10 here. Now, why is that clear strategic winner for a point? Well, if I get my ruler out, you can see on the screen, I'm going to draw a tangent line at that point. What's the slope of this tangent line? Well, the slope is 0. It's a horizontal line. So that tells me that the derivative function of this, inverted parabola is going to have a point at 10, 0. So that would be here. Okay, now the other strategic point I picked was x equals 5. And if you're wondering why I picked 5, because in part B of this question, I actually ask you to estimate the first derivative of this function. And I think I named it q. So y equals q of x. I told you to estimate q prime of 5. So let's go ahead and figure out the tangent line at 5. And we'll use a different color. Let's use pink. I'm going to draw this point right here. And let me get my ruler out. And then with my ruler, I'm going to try to make it match the slope of this line here. So the slope of q at this pink point. So clearly right now, if my ruler is like this, it does not share the same slope as q. My ruler is like that, it doesn't share the same slope as q. So I'm going to get in very close. And in fact, let me zoom in a bit more. Let me try to get it just right. So now I'm going to move my ruler again. And I'm going to carefully get it to match up. I think that's a pretty good match. And draw my line. Now let me zoom out. There we are. And I can hide this ruler. So now I'm going to try to figure out what this slope is. So using my own technology, I could easily pick up this line and move it and see how it fits on a couple of points. But if you're using this on paper, you can't. But what you can do is get your ruler and see how it's not quite at nice grid line intersection points. I can move it to some grid line intersection points. So this ruler has the same slope as my tangent line. And check this out right here at this point and this point. Let me hide the ruler. So I know the rise of my line is up these two boxes and over to the right. But remember, the rise here, this is actually 10 units up and 1 unit run. So the slope here is m equals rise over run equals 10 over 1. So m is just 10 here. That tells me that at 5, at x equals 5, the derivative function q will have a slope of 10. Now, if you didn't see this, if you didn't think to move your ruler to a nicer spot, well, then just make an estimate. It might not be exactly 10, but it should be fairly close. And what I mean by estimate, choose 2 points. I'm going to choose my point here, 5. And at 5, I would guess the output of this function at x equals 5 to be maybe, what does that look like, 13? So I'll say my guess is that this point here is 5, 13. And let's pick another point. I'll say right here at 6. Ooh, that's a little low. Okay, and I'm going to guess that this point here, does it look like 23? Looks kind of like 24. Looks kind of like 24 to me. So 5, 24. And then you can use these 2 points to estimate the slope of the tangent. So that would be 24 excuse me, I made a mistake here. Oops, that should not be a 5, that should be a 6. This is the point 6 here. Let me fix that. There we go. There. So 24 minus 13 over 6 minus 5. What is that? 11 over 1, 11. So it's pretty close to 10. It's fairly close to the estimate. So if you were using this method, you would say the slope or the point on the tangent line would be 5, 11. Now these points that I'm estimating here, either 5, 10, 10, 0, or 5, 11, and 10, 0, these are points on your tangent line. So the slope gives you the output, the y value, on the graph of the tangent line. So now if I were to graph this, and I'll use this point and this point. So I'll highlight the points I use. If you got like 11 or 9 or something really close, you'll still get credit. I just need you to justify how you found the slope of that line. So let's graph this. If I use 5, 10, then I'm going to graph at 5. I'm going to go here to 10. And then my other point I'm using is 10, 0. So at 10, 0, that one's right here. And then you can just connect these points. So let me get my ruler out again. Oh, and I accidentally erased my points. When I scratch it too much with my pen, it thinks I'm erasing. I'm not erasing. There we are. Okay. And I'm going to sketch my tangent line right there. Be really careful at your start and end points for your tangent line. Remember, this curve has a particular domain that doesn't extend to the left beyond something or to the right beyond something. I'm not going to say more, but it doesn't extend beyond that. So right here, what I have just done is sketched y equals q prime of x. And remember, we have q of x right here. All right, keep calm and math on.